Um, April 27, new learning has started. New learning is kind of weird for us. We've been supposed to be doing other learnings. You'll notice that around noon today, uh, several assignments might have also been added. Those are mainly because if you registered for Calc 2 for Central, one, talk to Lozano. She's been sending stuff out. I've been trying to connect you to. Thank you for all of you that have. If you haven't, that's fine. You're awesome. I got your back too. With whatever you got to do to just, graduate. Get math out of the way. Don't do that. Math is awesome. Oh, please, at any time, if I'm rambling, scrub the YouTube slider forward. Okay, so point being, we got to get ready for the Calc 2 final, and I'll be putting some more stuff into the AP Classroom, just practice tasks. Y'all are really ready. It's just put your practice in. Anything that we're doing now is just trying to fill up the corners. It's like the little desserts at the end of a large meal that you're just, starting to kind of feel like, all right, what else is there? Have we really fully explored all that we need to do? There's two main things left that we have to talk about, and this video brought to you in part by my cat Gilbert. She doesn't like that. This concept today is on volumes, and there's another one on work that we need to be talking about. But really, we've done all the work for it, so let's wrap it up. Keep practicing, keep pushing your expected assignment for are we communicating and doing things right? Is that you're getting 5% further? It should be higher, honestly, but I'm trying to hold you to a minimum standard. 30 minutes a week, you should be putting in way more. If you're sitting at like an 85%, you've technically done what I asked you to do before COVID started, and that's awesome, but why stop there? I don't have a statement for you about what that means in terms of, are you going to get an A or not? I mean, just do your work and you'll be fine, right? We'll have any conversations if you need to. Still rambling, getting ready to talk about a task. I have nothing further. Okay, now, this is when you should start listening. Applications of integration in the AP Calc AB. We're going to do one together. I've done a couple of videos like this already. I've got the paper handy. I'm going to use Desmos. I suppose I should be showing stuff off of the calculators. I don't really know what the school is going to do. I'll put that in my notes. Use of TI Calcs for the final and AP test. I mean, if you have the ability to, it'd be a good idea just to try to obtain your own. But I know that we've been distributing technology as students have needed it. And so, okay. So I'm not sure what instrument you're allowed to use, whether it's a TI calculator or Desmos. I'm going to assume that no Desmos is going to be allowed to be used on the final. But I also don't know how the final is going to be secure, or the AP test for that matter. So I'm not entirely sure what instruments or calculators you can use on any of the tests that you have left to take. But I'm going to assume that it's still going to be standard procedure, which is no Desmos. And so until I hear otherwise, or until I've asked the powers that be what their options or considerations are, we'll figure it out. Okay. Now, we're going to go into Khan Academy. And in Khan Academy, we've been talking about several things that integration affords us. My last couple of videos were on volumes. Please feel free to look those up and get those taken care of. And sorry if I'm causing you to get dizzy as I scroll. There's a lot in this topic. It's the final major one for the course. Any of the AP practice would be good. Go ahead and do the AP practice, which is, just further on down in the Khan Academy section. The AP Central also has some good stuff for you to do too that we've been using, so feel free to use that. That's what the questions have looked like. Anyway, point being, we're going to talk about something called the DISC method for revolution. Here we go. Start. DISC method for revolution around X or Y axis. Let's go. Full disclosure, I haven't done these questions before on Khan Academy. I've done them out of the textbook. I've done them out of other resources. Spent my own time practicing them. So I'm going to work my way through it. And if I'm wrong, we'll I'll share that process on why I thought it was wrong and whatever. Of course, feel free to double time speed this. Make it be meaningful for you. Let R be the region enclosed by the y-axis. Okay. The line y equals 2. Okay. That's visualizer. Everything's crummy about my device right now. The line y equals 5, and then this curve y equals e to the x. And a solid is generated by rotating r about the y-axis. I'm going to pop over to another website for a second and just talk about solids of revolution, because I want to share with you some of the image you should be thinking about as these are created. I mean, we're really talking about this curve getting rotated. This is around the x-axis. Imagine what it would look like if it's rotated around the y-axis. Let's get some other images in here. Solids of revolution is such a hugely important concept that I can't take lightly, but I want you to kind of get the idea. This red line is square root x. If I take that and I spin it, it's like a saw blade really, really fast. Eventually, it creates this solid shape that you don't want to try to touch because you get your fingers chopped off. So it's spinning so fast, you can just think of that entire purple region as a solid object. Or it actually, physically is. You're making something on a 3D printer and you need to tell the computer what sort of 3D shape you want. You can get a lot of traction by saying, draw this line, rotate it around an axis, what shape do I make? And so that's what this section is on. Here's kind of like a 3D picture of an outside parabola cone with a funnel taken out of the middle. And so we can talk about subtracting volumes, just like we can talk about subtracting areas. I'm not into this one, but I just want to give you an idea. This is what we're trying to do as we talk about what a solid of revolution is. And this is called the disk method. Notice this one. I like this one a lot. You take a circle and you rotate a circle around the y-axis. You get a torus. You said donut. Okay. Although, certain types of donuts. So this one, I'm going to try to sketch it a little bit. And do I have visualizer working? Yes, good. Okay. So when it's drawn, here at 2 and 5, the curve's going to go up and it's going to make this circle. Something, circle's off, but something like, this shape right here. And then you have this like a bowl, it's got like a flat bottom here, and it's got a bigger top, and then it's got curved edges. So maybe that's the right way to think about it. A solid bowl filled with milk, there it is, you're holding it. What's its volume? That's what we're going to find out. We'll need to use the fact that the formula for volume is still going to be base times height. As in the area of a cross-sectional base. This is called the disk method because we really are trying to take a bunch of, disks, track and field disc, or this is out of relevance, but a DVD disc or something like that, and just stack them over and over and over, like the layer cake problem that we did a while ago, because the layer cake problem was this problem in advance. A whole bunch of layers of cake stacked on one another. Full of analogies today. Each of those layers is a cylinder, and the formula for the volume of a cylinder is pi r squared times height. Pi r squared because the cylinder has a circle base. So for us, we've got some limits of integration. The other key thing to note is that we're going from 2 to 5. So if we're going from 2 to 5, those are y values. And we can't use y equals e to the x because that's solved for y, and we're going to integrate a y function in terms, a function x in terms of y. So I got to do some math magic, and we're going to come up with x is the natural log of y. Doesn't matter. Okay, so get a function in terms of y so that we can integrate from 2 to 5. And our formula, our volume formula, will become the integral from y equals 2 to y equals 5 of pi times r. R is going to be this distance out from the center y-axis to the curve. So it's this allowable outside, so natural log of y dy. And this is squared, can't forget the squared, so pi r squared. Height is from 2 to 5, so h is really taken care of by the 2 and the 5 right there. Okay, pi doesn't need to be in the middle of the calculation. Pi can come out to the front. It's just a constant. So to go from 2 to 5, we'll put pi on the outside. of the natural log of y dy. Okay, I need to remind myself. And this is where like going through your parent function derivative, parent function antiderivative, and just keep like repping those for polynomials and trig and exponentials would be helpful. Logarithms. I think the antiderivative of wait. Okay, I'm getting another like mind again. I haven't done this one yet, so I'm trying to work my way through it. I can't just straight up take this. I have a square involved, so I need. Oh, this is gonna be a pill. I'm gonna. You're seeing my angst on my face if it's coming through. Oh my god, computer! I can't type parentheses with this computer. It is irritating. I take that number and I take the pi out of it. There's something I have to do here. Oh, hey, look at that. I don't need to actually answer the question. Okay, so visualizer, I've thought about how volume is base times height, and the base is a circle. I just have to look at it with y values instead of x values because we're rotating it vertically, which means that we're using a function in terms of y, not a function in terms of x. Having that out of the way, my limits of integration are going from 2 to 5. I have pi r squared in there, so yeah, check this out. B is the answer I'm going to go with. Check it. Okay. Pause the video here. I'm going to go ahead and, or the video will stop here. I'm going to go ahead and do the remaining questions like the other videos that I've had. I'll call it behind the scenes, BTS. Is that what that really is? Okay. Anyway, I'm going to upload those a little bit later, but try to get them all done in there today. Certainly my deadline is 12 noon every Monday. But for you guys available. Oh, this video brought to you by a meme. It's important because the AP test and the final for Central, and I don't know, just being good at math. Okay, also, this video brought to you by the letter T, because T is for 10, and T is for Tuesday, and T is for Thursday. So expect some sort of like, me available here, live meet on Tuesdays and Thursdays. Feel free to watch any other videos that I've posted. And of course, put it on double speed and just, zip through it. Too long of a video, I realize. Thank you for watching, commenting, liking, subscribing, ringing the bell, letting me know how awesome you are. We're all awesome together. Be awesome because math is awesome. Thanks. Bye.